this is a horrible, nasty question, and we're going to use tons of eigenvalues. I'm going to try and simplify it in certain points instead of writing out long strings of eigenvalues by using summations, but the best way to learn this is to really write it out as best as you can. So firstly, let's simplify what we've been given here into eigenvalues. So the first thing that we're going to do is do S1 is going to equal the eigenvalue 1, 2, and 3. S2 is just going to be the exact same thing added together, but each term is squared. I always like to write it like that. It seems a bit silly to be very pedantic about this in the beginning, but trust me, when you're dealing with this later on and you have loads of 1, 2s, and 3s flying around, it's always better to write down the eigenvalue number and then whatever it's squared to after. So then you're going to have the same for S3, and that's all going to be to the power of 3. And then we have D. D is the determinant of E, which is the eigenvalues multiplied with each other. That's what the determinant is. So let's begin representing this in eigenvalues. So let's substitute everything in. So we know that we've got S3, which is all to the power of 3. I'm just going to put brackets. Brackets aren't totally necessary there, but we might as well. 3, which is S2. So you're going to have the eigenvalues 1, 2, 3, all to the power of 2, multiplied by, I'm just going to start that here, 1 plus 2 plus 3 minus 2 S3, which is 1, 2, 3 to the power of 3, plus 6 to the determinant here. And remember, these are not, there's no addition, they are multiplied together. I'm going to simplify it out a little bit, and we're going to let A equal the eigenvalues of 1, 2, and 3 added together. So that means we can start substituting that in a minute. But we need to remember an identity. We know that A plus B plus C all cubed is going to be A cubed plus B cubed plus C cubed plus 3 A squared B plus A squared C plus B squared A plus B squared C plus C squared A plus C squared B plus 6AB C. So do you see how I've now moved this from these eigenvalues into A, B, and C terms? But it's exactly the same. Every single part is exactly the same, with the exception of this A cubed, B cubed, C cubed. But it will connect together later. So let's now, we've got our A equals this, so let's substitute that in. This would then become A cubed will equal 3. Let me actually just do it how I said you should. And then we're going to have add that to 3 2y2 plus 1 squared y cubed plus y2 2y1 plus y2 2y3 plus y cubed 2y1 plus y cubed 2y2, let's close those brackets, plus 6, 1, 2, 3. So let's now group the first terms. So you're going to have A3 equals S3 plus 3 2 plus 2. No, wait, there should be a bracket here. Lambda 2 plus lambda 3 plus the eigenvalue 2 squared, 1 plus 3. Trying to keep track of everything here. Plus, so we're going to have an eigenvalue of the third one squared, 1 plus 2 plus 6d. Okay, so now we're going to factoring in for S2 and S1. And this is where I'm going to now do a little summation instead of writing everything out for 1, 2, and 3, 1, 2, and 3 for absolutely everything. It just takes too long. So we're going to have S2 and S1 is therefore going to be, we're going to now use, we've got these, haven't we? So let's go back to that. We're going to have 1, 2, 3 all squared, 1, 2, 3, and that's all going to equal the summation of I equals 1, 3, where that's I to the power of 3 plus, let's do the summation here, where I cannot equal j, and we're going to have I squared multiplied to j. So we now need to plug this all in one last time, and we should be able to prove that with eigenvalues. So if we do 3s 2s1, you're going to get 3s3 plus 3, and I'm going to do eigenvalues 1, 2, and then that's to 2 plus be 1, 2, and 3. Then that's going to be added to 2, 2, and 1 plus 2, 2, 3 plus 2, 3, 1, and the final one is going to have 3, 2, 2. So if we have A3 equals S3 plus 3S2 S1 minus 3S3 plus 6D, we can now just clean up because we've just sorted this out. I've skipped a few steps because this is just a case of factorizing. And we now can see that this S3 minus 3S3 is going to then be 3S2 S1 minus 2S3 plus 6D, which is the identity we had in the beginning. And so we've used eigenvalues, or we've represented it using eigenvalues to come up with what we started with.